Hi, my name is Kevin Santiago, and this is my grade 12 Advanced Functions CCT. I'll be providing a step-by-step solution on how to solve question 11 on page 346 of this textbook. A rung on a hamster wheel with a radius of 25 centimeters is traveling at a constant speed. It makes one complete revolution in 3 seconds. The axle of the hamster wheel is 27 centimeters above the ground. So 11A is asking us to sketch a graph of the height of the rung above the ground during 2 complete revolutions, beginning when the rung is closest to the ground. So the important parts to this question are actually the fact that the radius is 25 centimeters. It makes one complete revolution in 3 seconds. The axle of the hamster wheel is 27 centimeters above the ground, and we're asked to graph during 2 complete revolutions when the rung is closest to the ground. So already from the question, for 11A, we already know 3 things. We know the radius, we know the axis, we also know the period. So respectively, this is 25, 27, and 3. We'll only focus on the radius and the axis right now. So in order to graph our function, we actually need to know the 3 different heights. So we need to know the max, the min, and the equation of axis. So we can determine the max by adding the radius and the axis together. This is due to the fact that the axis is the center of the hamster wheel, and since we know that the radius of the edge from the hamster wheel to the center is 25, we can simply add the axis and the radius to get 52. And we can do the same thing, subtracting the axis and the radius together to get 2. So therefore we know that the max height of the hamster wheel is 52 centimeters off the ground, and we know the min is going to be 2 centimeters off the ground. The equation of axis is going to be the exact same as the axis, so we already know that, which is 27. So 11A asks us to sketch a graph of the height of the rung above the ground during 2 complete revolutions, beginning when the rung is closest to the ground. So what I always like to do is I always start with the x-axis, and since I know that the period is 3 seconds, I know that all I need to do is just add on 3 more seconds to get 6 seconds. So that is the length of 2 complete revolutions. So because I know it requires 4 points in order to graph a function, I divide 3 by 2 to get 1.5. Then I divide 1.5 again by 2 to get 0.75. Add on 0.75 to 1.5 to get 2.25. That's 4 points. Add on 0.75 until I get 6. So therefore, in total, I will have 8 points. 8 points are exactly what I need. So the next part of the question requires me to find my 3 different heights, which if you recall earlier, we actually already did. So the radius and the axis is 25 and 27. And by adding the 2, we get our max. And by subtracting the 2, we get our min. So the next part is just plotting our points. So if you just plot your points along the graph, all you need to do is just connect the dots and ensure that you do not have a V, because you'll lose some form marks. So it always has to be a perfect U and a straight curve. The next part of the question ensures that we have to label our axes. So I made a mistake here. That has to be Y, and this has to be your X. So you label your axes, and once you do that, you're done the question. So 11B asks us to describe the transformations necessary to transform y equals cos x into the function you graphed in part A. So really the only important part to this question is this part right here, y equals cos x. So for 11B, we actually need to do a series of 4 calculations in order to determine the transformations. So first of all, we need to find the amplitude, which tells us how far the graph has been stretched or compressed, and we also need to find the b value. The b value tells us whether the graph has been horizontally compressed or stretched, and by how much. Next, the phase shift. The phase shift can be determined by looking at the graph, and we can actually determine how far the graph has been shifted left or right from the origin based on the phase shift. Then the equation of axis. We actually already know this value, and what it tells us is how far the graph has been translated up or down from the origin. So for the amplitude, we can determine it by subtracting the max and the min values together, then dividing it by 2. The b value, we actually need to do some ratios. So it'd be 2 pi over b equals the period over 1. So we just cross multiply, and then we can isolate for b. The phase shift, we can look at, as I said before, we can determine it by looking at the graph, and the equation of axis we already know. So y equals cos x can look one of two ways. So if you remember from grade 11, it actually can start from the max down to the min, then to the max, or it can go to the min, to the max, then to the min. The difference is that in this case, your a value will be negative, and in this case, your a value will be positive. So now you have all the steps to find to do 11b. So for 11b, it asks us to describe the transformations necessary to transform y equals cos x into the function you graphed in part A. So right here, this is our graph. And if you remember earlier, I said that we need to do a series of 4 calculations. So the amplitude, the equation of axis, the phase shift, and the b value. So the amplitude can be determined by subtracting the max and the min together, then dividing it by 2. So we end up getting 25. The equation of axis, algebraically, you can add the max and the min, then dividing it by 2, and you get 27. So the b value is what's a little bit confusing. You need to do ratios. So you make 2 pi over b equals your period, which is 3 in this case. Then you cross multiply, then you isolate for b. However, when you're describing your transformations, you must always take the inverse of your b value. So in this case, our inverse would be 3 over 2 pi. Finally, our phase shift. So in this case, our phase shift is 0 because I decided to make our graph look like this. So if you remember, I said there are 2 possibilities for a y equals cos x graph. This is the second one. The reason why I chose this kind of graph is because over here, your graph actually starts at 0, so there's no phase shift at all, which in my opinion makes it a lot easier. So therefore, there isn't going to be a phase shift. And also, your amplitude is going to be negative. So once you do calculations, you can describe your transformations. So therefore, the graph y equals cos x has been reflected across the x-axis and vertically stretched by a factor of 25. It has been horizontally compressed by a factor of 3 over 2 pi and vertically translated 27 units up. So 11c asks us to write the equation that models this situation. It's actually the easiest part of the entire question. All we're really doing is taking the calculations we had done in 11b and applying it into the general equation of a cos x function. And once you do that, you're actually done the question. So 11c asks us to write the equation that models this situation. So since we determined all our values in 11b, all we need to do is just plug into the general equation for a cos function. So this is the general equation, and these are all the values we determined. So once you plug in all our values, we can further simplify this right here, and this is our final equation. So you conclude the question by your therefore statement. So therefore, the equation that models this situation is y equals negative 25 cos bracket 2 pi over 3x bracket plus 27. Real life application. So this is just one example of a query where you might encounter a problem like question 11. So say if you're a navigator and you wanted to determine when low and high tide would occur, you can graph water depth versus time. So the reason why you'd want to do this is, say your ship can only leave harbor during low tide. So using the methods in 11A and 11B, you can determine the period. And then using the method in 11C, you can make an equation that can help you determine the water depth at any point in time. So as a result, you'd be able to know when low tide would happen. So this is just one example of how you could use the methods in question 11 in a real life career.